Hello students, so let's try to solve one more problem from JEST 2022, and this problem is from quantum mechanics, and this is from the hydrogen atom. So the total wave function is given for the ground state, and the total wave function had quantum number 100 actually. So this has our ground state where r is between 0 to infinity, theta is between 0 to pi, and phi is between 0 to 2 pi. And what we have to do, we have to plot the radial probability density versus R. That means what will be probability such that electron will find between 0 to R distance. So we have to basically plot the radial probability density. So before plotting the radial probability density, let us try to analyze this wave function. This is complete total wave function, means angular part as well as radial part is there. If we will just separate the two part, then we can have R10 Y00. So this is radial wave function and this is your spherical harmonics for the ground state. And this value is equivalent to 2 upon A naught 3 upon 2 e to the power minus R by A naught, and spherical harmonic y00 is 1 upon root 4 pi. If we will combine this thing, we will get this one. And this is my radial wave function. So we have a radial wave function R10, that is 2 upon A naught 3 by 2 e to the power minus R by A naught. And 2 by A naught 3 by 2 is normalization constant actually. What we have to do, we have to plot the radial probability density. So we have to be very much careful that the probability is defined as rho r dr, and this will define that electron will find between distance r to r plus dr, and this will equivalent to r10 mod square r square dr. And when we are going to compare these two things, then radial probability density rho r is equal to r10 mod square r square, and this is actually 4 upon A naught cube e to the power minus 2r upon A naught into r square, where r is varied between 0 to infinity. So we have to plot this particular plot. So let's try to plot this one. So obviously we can see at r tends to 0, rho r is 0. So r tends to infinity, again rho r is 0. So, and we will check that whether r is equal to A naught, we have maximum probability, which is most probable distance also. We all know this thing. So, and we can also find it from the differentiation. So what we can do, we can just go for d rho upon dr must be equal to 0, which will just give us, this is constant value. So this will take a net. So we will take it constant. So e to the power minus 2r upon A naught, and we will differentiate r square. So that will be 2r. And again, we will take r square common and we have to differentiate this one. So this will be minus r square 2 upon A naught e to the power minus 2r upon A naught must be equal to 0. So, and yes, this is constant. So hence right hand side 0. So we have to only consider this one. So when we are going to calculate this one, we will easily find e to the power minus 2r upon A naught into 2r, we can take common. So we have 1 minus r upon A naught is equal to 0. Hence, at r is equal to 0, we have radial wave function is 0. And r is equal to infinity, we have radial wave function again 0. So at the finite local maxima will be find at r is equal to A naught. So we can easily check it at r is equal to A naught is local maxima. So how we will plot it? So when we will go for this particular rho r versus r, so we have something like this and it will go like this. And we have to always take care that this radial probability density is skew symmetric towards right. That means it is not a symmetric about rho r is equal to A naught. So more area will cover toward the right of A naught, less area will cover into this part. So But in this option, only one curve is something like this. So we have option D as a correct option. So this will be option D. So it's a very simple question, and it's a only one thing you have to identify what is the definition of radial probability density. In general, people do error that they will just take the mod of this thing. So that will be something different curve. That is exponential curve. But due to multiplication of this R square, so this whole thing is radial probability density. That is the most important concept. We have to work on this thing. So why this problem was asked into your exam. So just you have to practice this type of question. This is very simple one, conceptual one. Not very high level of mathematics is there. And so why this is one easiest problem you can say in your exam. Thank you.